In this goal, we will look at physical and chemical properties and physical and chemical changes. So each substance has a unique set of physical and chemical properties. And the physical properties, those are the ones that can be measured without changing the substance. So looking at a piece of paper, I can see that the paper's white. I can see it's a certain shape. I could take the mass. I could say that it's a solid. These all describe that the physical property of the paper. For chemical properties, I would need to actually change that substance to show the chemical properties. So one of the chemical properties of paper would be that it's flammable. So as soon as I demonstrate that, I would then change that substance into something else. So again, physical properties, it stays the same. It stays the same name, so to speak, but chemical properties would change it. So that paper, if I demonstrated its flammability and I burn it, I wouldn't have paper anymore. I would have ash and some smoke. Properties can be categorized as intensive or extensive. Intensive properties, it doesn't matter how much you have. So if I had that piece of paper, maybe had a very, very large piece of paper, or maybe I had a little tiny piece of paper, I could still say that both the papers are white. So it doesn't matter how much paper I have, it would still share those intensive properties. Your extensive properties have to do with the quantity that you have there. So my larger piece of paper would have a larger mass, my smaller piece of paper would have a smaller mass. So that would be an extensive properties. So when we are classifying matter, we more look at the intensive properties to describe, for example, what a piece of typing paper is. The extensive properties, again, describe how much is there. How much do we have? Maybe I have a whole ream of paper. Maybe I just have one piece. Just test yourself and see if you can figure out if these are physical or chemical properties. And if it's a physical property, classify as intensive or extensive. So stop the tape and see if you can figure it out. We have the chemical is blue. Well, that doesn't matter how much I have. So this would be a physical property, first of all, and it would also be intensive. And we're back. Let's look at number one. So number one, the chemical is blue. So this is describing a physical property. And if it's a physical property, you need to say whether it's intensive or extensive. And it doesn't matter how much I have of it. This is going to be blue, regardless if I have a lot or not. So this is intensive. The metal rests in the rain. So notice the metal is turning into rust. So because it's turning into something else, this is a chemical property. And I don't have to classify if it's intensive or extensive if it's chemical. Number three, the density of water is 1 gram per milliliter at 25 degrees Celsius. Be careful with numbers such as density. So it doesn't matter how much water I have. I can have a bucket of water. I can have a glass of water. As long as I'm at 25 degrees Celsius with that water, this is what my density will be. So this is a physical property and it's intensive. Again, it doesn't matter how much I have. It will be the same density. And the last one, the mass of the metal is 10 grams. So just taking the mass doesn't change it to something else. So this is a physical property and this is extensive. So again, an extensive, the amount is important there. And so I have a measurement here of mass. So I think of like mass or volume, weight, those would all be extensive properties. How'd you do? Let's look at physical versus chemical change. In a physical change, you're just changing the shape or the size of the substance. So if I took that piece of typing paper, I could rip it in half, and that would be a physical change. So now I have a smaller piece of paper, but I can still call it a piece of paper, so the name doesn't change. In a chemical change, this is a reaction. It's a change in identity. I can change it to something else. So again, I can burn that paper and have ash and smoke. So in chemistry, we use what's called reactants and products. So reactants is what you start with and products is what you end up with. So let's say I take my reactants and I'm going to say it's my piece of paper. And let's say I take that paper and I light it on fire, so I combine it with oxygen, which is also a reactant. Then I'm going to get my products. My products is going to be ash, and I'm just going to say smoke. So not a very technical equation here, but notice that reactants are over here, what we start with, and products are over here. So just to recap, Signs of physical change would be a new shape, a new size, a new state of matter. So if you had ice and you melted it to a liquid, that would just be a physical change because it would still be H2O or it's still water. It just went from frozen water to liquid water. But in a chemical change, you would get a new color that's unexpected. So maybe there's two clear liquids and you put it together and it turns purple. Well, that's unexpected. That would be a chemical change. Sometimes there's a smell that develops, or you might see bubbles, and so a gas is formed. You might have a solid that appears, and you might also see heat given off, or maybe it feels cold. Pause the recording and take this little quiz to see if you can figure out if it's a physical or chemical change. Okay, let's come back. I think I already gave this example. An ice cube melts into water. That is a physical change. A sugar cube is crushed into powdered sugar. Also physical change. It's still sugar. A marshmallow is toasted over a fire. This would be chemical change because now I have a toasted marshmallow. A marshmallow is cut in half. A physical change. So let's look at the first separation mixture, filtration. So this would be if a solid forms when I put two solutions together. I could use a piece of filter paper. I could have the liquid go through this little piece of filter paper, and then I'd have my solid here separate from my liquid. So you do this when you make macaroni and cheese. You boil the noodles and then you strain off the water and the noodles are left in your strainer. Distillation is when you have liquids that have different boiling points. And so you can take your mixture right here and you can heat it. And then this right here has a jacket of cold water. And the gas, after you heat it, it becomes a vapor or a gas. And then it condenses back into a liquid. And I can control the temperature to separate out. So the lowest temperature would come out first. This is exactly how they make alcohol. They'll take their mixture of corn and barley or whatever grain that they have there and they'll let it ferment and make the alcohol. And alcohol boils about 80 degrees Celsius. And of course, we know that water boils at 100 degrees Celsius. So they'll just make sure to keep the temperature of this at 80 degrees, and then the alcohol will come out first, and then the water will be left back. There are some people that make their own alcohol at home, but you want to be very, very careful because there's different types of alcohol out there, and if you don't know what you're doing, you can make the type of alcohol that just one glass of can make you go blind. So it attacks your optic nerve. So make sure if you are distilling for alcohol, you know what you're doing. Let's look at chromatography. Chromatography is when you use the polarity of the molecules to separate them out. And you can do this little experiment at home. This experiment right here with the green, they took a leaf and crushed up the leaf and put it in a little spot right here. And then they stuck it in a little bit of alcohol here. Just rubbing how alcohol would work. And then you can see how the colors separate. The yellow color is very attracted to the alcohol, so as the alcohol goes up, the yellow will move, and then the green is more attracted to the paper, so it stays behind. But you can separate that out. You can do something like this at home with food coloring. So you can put a drop of food coloring right here on your piece of paper, and then you can stick this in water. And then you can see the colors separate. So you can try it with, I know red food coloring has a couple of dyes in it, or you can take a mixture of food coloring and make like a black color and then separate it out. You can do it with pens too. Fractional crystallization is when you exploit the solubility of different substances. So both of these solids, KNO3 and table salt, when I heat up my liquid or my water that it's in, you can see that you can dissolve a little bit more. The sodium chloride doesn't change too much, but that KNO3 really does change. I can dissolve more. So what you can do is, if you had a mixture of both the NaCl and the KNO3, heat it up and dissolve both of them, but then you can cool it down. And you can see that at this point right here, I'm going to have solid KNO3. So I'll be able to separate that out. So past the temperature of about 20 degrees, I'll be able to start separating out that KNO3. Maybe not all of it, but a little bit of it.